Welcome to the Deep Dive. Forget what you think you know about making software smoother. Today, we're diving into agents, a new breed of intelligent systems powered by large language models, or LLMs. Think of it. Instead of just automating existing steps, these agents can handle complex, multi-stage tasks all on their own. We've got some really fascinating material here that gets down to the nuts and bolts.
Exactly. You know how regular software streamlines a process you've already mapped out? What's truly game-changing here is that agents can kind of figure out the map as they go.
Right.
So our goal in this deep dive is, well, to give you a clear understanding of what these agents are, when they're the right tool for the job, because let's face it, they're not always the answer.
Good point.
What makes them tick, how you can structure them, and crucially, how to keep them operating within safe boundaries. The insights we're pulling from this guide, they come from real-world deployments, so it's practical, actionable stuff you can really sink your teeth into.
Okay, so let's cut to the chase. When we talk about an agent, what does that actually mean? The material we have defines it pretty clearly. An agent is a system that independently gets things done on your behalf.
Yeah, and that word independently is key, isn't it?
Totally. We're not just talking about your usual software that follows a preset list of instructions. Agents actually manage the entire process, start to finish.
Right, like imagine a customer service issue. Could be a dozen steps, right?
Mhm.
Identifying the customer, understanding the problem in their own words, checking history, product availability, maybe processing a refund, confirming it all. A typical system might automate one or two steps there, but an agent can potentially handle that whole sequence, making decisions at each stage based on the info it gets. What's really cool is how it adapts. It's not just blindly following a script.
But to make sure we're all on the same page, the guide also spills out what isn't an agent, because that's important too. We're not talking about simple chatbots that just answer your questions in one go, or LLMs doing a single task like summarizing text, or, tools that just analyze sentiment.
Right.
The crucial difference is that agents take ownership of that multi-step workflow execution. They're the ones driving.
That's a really important distinction. So what are the core ingredients then? What makes up a true agent? The guide highlights a couple of essentials.
Okay.
First, an agent uses an LLM, a large language model, not just to understand language, but to actually manage the whole workflow and make decisions.
So it's the brain, basically.
Kind of, yeah. And that includes knowing when a task is actually done and even proactively trying to correct things if they go wrong.
Yeah.
And interestingly, if it gets stuck, it can pause and ask a human for help.
Right. It's not just on autopilot going off a cliff.
Yeah.
And the second crucial piece.
Access to a set of tools. These are external functions, or APIs, application programming interfaces.
Okay, so ways to interact with the outside world.
Exactly. Think of them as ways for the agent to reach out, grab the information it needs, and take actions. What struck me is that it dynamically decides which tool is the right one for the moment. Within guardrails, of course.
The guardrails. We'll definitely need to talk more about those later.
For sure. So you've got the LLM as the brain making decisions, and then the tools are like its hands, gathering info, taking action. That intelligent selection of the right tool, that's where a lot of the power and flexibility comes from.
Okay, so now we have a good handle on what an agent is, but, when should someone listening actually think about building one? The guide makes it clear this isn't just about slightly better automation. It's a different way of thinking about decisions and complexity.
Yeah, it's a real shift. And what's truly insightful here is that agents really shine where traditional rigid automation just hits a wall. Think about those workflows that are just too messy, too unpredictable, too nuanced for a fixed set of rules. Well, the guide uses a fantastic analogy. Payment fraud analysis. A traditional rules engine is like a checklist, right? Does it meet condition A, condition B?
Okay, yeah, tick, tick, tick.
But an LLM agent, it acts more like a seasoned investigator.
Yeah.
It looks at the whole picture, the context, spots subtle patterns, weird anomalies that a simple rule would just totally miss.
That's a great analogy. It really clarifies the difference in reasoning, like human intuition almost.
Kinda, yeah. That's the potential aha moment. And the guide gives us some specific criteria for when to seriously consider an agent.
Okay, let's hit them.
First is complex decision-making. Scenarios needing nuanced judgment, lots of exceptions, or where context is everything. Like, should we approve this tricky customer refund?
Right, not just a simple yes-no based on one rule.
Exactly. Second situation, when you have difficult to maintain rules, those systems where the rules are just this tangled mess.
Oh yeah, updating them is a nightmare, break something else.
Precisely. Things like detailed vendor security reviews often fall into that category. Agents can potentially handle that complexity more gracefully.
And the third one.
A heavy reliance on unstructured data. This is where LLMs really shine, right? Understanding natural language, pulling meaning from documents, having real conversations. Think about processing complex home insurance claims, reading descriptions, looking at photos maybe.
Got it. So complex decisions, messy rules, or lots of text and conversation.
That's the core idea. But, and this is important, the guide advises you to really check your use case against these points first.
Don't just jump on the bandwagon.
Exactly. If a simpler deterministic solution works, that's probably still your best bet. Saves time, resources, complexity.
Makes perfect sense. Okay, so let's say we've identified a good problem. What are the actual building blocks? The guide breaks it down into 3 key things: the model, the tools, and the instructions.
Yep, those are the essentials. The model, as we said, the LLM. The brains, the guide touches on the trade-offs. Bigger models might be smarter, but slower, maybe costlier. Smaller ones might be faster or cheaper, but maybe not handle the really complex stuff.
Right, finding that sweet spot. Then the tools.
The hands, those APIs, the ways to interact. And it's interesting, the guide mentions that even for older systems without APIs, agents might be able to use like computer vision models to interact with the user interface.
Wow, so controlling the mouse and keyboard almost?
Potentially, yeah.
Yeah.
It opens up possibilities for legacy systems. And the third piece, the instructions. These are the explicit guidelines, the rules of the road for the agent.
The operating manual.
Exactly. What to do, how to behave, what the boundaries are. It's like it's rulebook and ethical code combined.
The guide even shows a bit of code using OpenAI's Agents SDK to illustrate how these fit together. But, the concepts are transferable. You could build this stuff yourself or use other libraries.
Absolutely. The SDK is just one way to implement it. So, let's zoom in. Choosing the model. What's the thinking there?
Well, the guide recommends a pretty smart strategy, I think. Start with the most capable model you can access for your task.
Go big first.
Yeah, to set a benchmark, see what's actually possible. You do this using evaluations, evals, to test performance systematically.
Okay, establish the ceiling.
Right. Then, once you know what good looks like, you can experiment with smaller, faster, cheaper models. See if they still hit your accuracy needs. Optimize for cost and latency after you know the potential.
That makes a lot of sense. Don't leave performance on the table unnecessarily, but also don't overspend if you don't have to. Aim high, then optimize down.
Exactly. Now, let's dig into tools a bit more.
Right.
We said they're the agent's connection to the world via APIs. The guide stresses they need to be well-defined, well-documented.
So the agent knows how to use them properly.
Yes, and reusable, ideally. So you can use the same tool across different agents or tasks.
Yeah, that standardization is key for scaling, right? Like having interchangeable parts.
Yeah.
Makes everything easier to manage. The guide categorizes them too. Data tools for getting info, database queries, web searches.
Right.
Action tools for doing things, sending emails, updating records, and then, interestingly, orchestration tools.
Where agents can be tools for other agents.
Exactly, which kind of hints at the multi-agent stuff we'll get to later.
Okay, cool. And there's that code snippet showing how to give an agent a web search tool and a custom save results function. That, at Function Tool Decorator, looks pretty straightforward, basically flagging a Python function as usable by the agent.
Yeah, it wires it up. And a practical point the guide makes, if one agent starts needing tons and tons of tools, that might be your cue to break the task down.
Split the work.
Yeah, maybe multiple specialized agents are better than one overloaded super agent. Manages complexity.
Makes sense. Okay, third building block, instructions. The guide really hammers home how critical these are, maybe even more critical than for simpler LLM uses.
Absolutely, because the agent is making decisions based on them. Ambiguity is the enemy here. You need clarity for reliable results.
And there's some great best practices, like leverage existing documents, SOPs, support scripts, policies. Don't reinvent the wheel if you don't have to.
Right. Use what you've got and prompt the agent to break tasks down. Small, clear steps.
Define clear actions for each step, too. Not just solve the problem, but step 1, do X. Step 2, call tool Y. Be specific.
Specificity is key. And think about edge cases. The real world is messy. What happens if something unexpected occurs? Your instructions need to cover that conditional steps alternative paths.
Build in that resilience. handle the curveballs. And fascinatingly, the guide even suggests using advanced models to generate initial instructions from existing docs, like feeding it a Help Center article and asking it to draft the agent's instructions.
Whoa, that could be a huge time saver, getting that first draft automated.
Definitely could help get things off the ground faster. So we've got the model, tools, instructions. Now, how do we make them work together effectively? Orchestration.
Right, putting it all together. And the advice here is start simple. Iterate. Don't try to build the ultimate fully autonomous system on day one.
Crawl, walk, run. Makes sense.
Hmm.
The guide splits orchestration into two main buckets: single-agent systems and multi-agent systems. Let's start with single agents.
Okay, so one agent potentially doing many things just by adding more tools to its belt keeps things focused initially.
And the core concept here is the run. Can you unpack that?
Yeah, think of the run as the agent's execution loop. It's constantly cycling. Think, use a tool, evaluate, think again until some exit condition is met.
Like what?
Could be calling a specific final output tool or just generating a response without needing more tools. Or maybe it hits an error or runs out of turns, like a maximum number of back and forths.
Okay, so it keeps going until it's done, or stuck, or told to stop.
Yeah.
The guide mentions runner.run in the SDK example.
Exactly. That loop is fundamental, even when you have multiple agents later. It's how they operate.
And managing complexity in a single agent, the guide mentions prompt templates with policy variables. What's that about?
Ah, yeah, that's clever. Instead of writing tons of slightly different prompts, you have one main template, but it has placeholders, variables. You can change the agent's behavior, its policy, just by tweaking those variables. Much easier to maintain and test.
Like a Mad Libs for agent instructions.
Sort of. A very structured, powerful Mad Libs keeps things consistent. But there comes a point where even a single agent gets overwhelmed.
Right. When do you move to multiple agents?
The guide suggests a couple of triggers. One, if the logic gets super complex, tons of if this, then that branches, the prompt just becomes unwieldy.
Hard to read, hard to update.
Exactly. And the other is tool overload. Especially if you have lots of tools doing similar things, it confuses the agent, maybe. Even if the total number isn't huge, having too much overlap can be assigned to specialize.
Okay, so complex logic or too many overlapping tools, time to think multi-agent. Let's dive into that. Lots of ways to structure them, apparently, but the guide highlights two common patterns based on user experience: manager and decentralized.
Yeah. Think different org charts for your AI team. The guide uses a graph analogy. Agents are nodes, connections are edges. In the manager pattern, those edges are tool calls. In decentralized, they're handoffs.
Interesting. But the core ideas, flexible parts, clear prompts still apply.
Absolutely. Those fundamentals carry through. So the manager pattern, what's that look like?
You have a central manager agent, the coordinator. It delegates tasks to specialized agents by calling them as tools.
Ah, okay. So the specialists are just tools from the manager's perspective.
Exactly. The manager handles the overall flow, talks to the user, farms out the work, gets results back, synthesizes them, like a project manager with a team of experts.
Got it. Good for when you want one point of contact controlling things. The guide has that translation example, right? Manager calls the Spanish agent, then the French agent.
Yep, using the agent's SDK. Shows how the manager calls those other agents, and just like it would call a web search tool.
And the guide contrasts this code-first flexibility with more rigid graph-based frameworks where you have to define every possible path up front.
Right, saying that predefining everything can get really brittle, especially for dynamic workflows where things change.
Yeah, that code-first approach gives you more adaptability for the messy real world. Okay, what about the decentralized pattern?
Here, agents are more like peers. They hand off tasks to each other based on specialty. It's a one-way transfer of control.
Implemented as a special kind of tool call in the SDK.
Exactly. When Agent A calls the handoff function for Agent B takes over immediately. And crucially, the whole conversation state goes with it.
So Agent B knows everything that happened up to that point, like passing the baton in a relay race.
Perfect analogy. One expert finishes, hands off directly to the next. Good when you don't need a central controller, and specialists can just take full ownership.
Like that customer service example. Triage agent figures out it's an order issue, hands off to the order management agent.
Precisely. The code shows that flow. Initial message to triage calls the handoff tool, order agent takes over. It even notes the second agent could hand back if needed. Seems great for routing inquiries.
Yeah, conversation triage makes a lot of sense for that pattern. Okay, so we have these powerful systems, single or multi-agent, but with great power.
Comes great responsibility.
Yeah.
And the need for safety, guardrails. The guide spends serious time here.
As it should. Managing risks, data privacy, brand reputation is paramount. The key idea is layered defense.
Not just one safety net.
Right. Design guardrails for specific risks you identify. Layer them up. Combine LLM-based ones that understand context with simpler rules-based ones, maybe even external checks like the OpenAI moderation API for input vetting.
Defense in depth. Makes sense. What kinds of guardrails are we talking about?
All sorts. Relevance classifiers keep the agent on topic. Safety classifiers spot bad inputs like jailbreaks or prompt injections.
PII filters.
Yep. Stop personal info leaking out unnecessarily. Moderation for harmful content, hate speech, etc. Tool safeguards, assessing the risk of each tool.
Like, does it write data? Cost money? Is it reversible?
Exactly. Trigger extra checks or human approval for high-risk tools. Then you have simpler rules-based protections, block lists, length limits, rejects patterns, and output validation. Does the response sound like us? Match our brand values.
Wow, that's a comprehensive list. It feels like building a security system layer by layer.
It is, and the practical advice is, start with the big ones, data privacy,
Yeah.
content safety. Then add more based on real-world failures or edge cases you find. Always balancing security with user experience. You don't want guards everywhere stopping legitimate use.
That iterative approach again. Learn and adapt. There's a code example too, right? For an input guardrail.
Yeah, churn detection agent. It uses the @input guardrail decorator. If the guardrail agent, running before the main agent, detects a high churn risk in the user's message, it throws a specific exception. Guardrail tripwire triggered.
So it flags potentially risky conversations before the main agent even processes them fully.
Exactly. It's an early warning system built right in. And the guide mentions the SDK uses an optimistic execution approach it tries to run, but the guardrails are checkpoints.
Got it. And even with all these automated checks, human oversight is still vital.
Absolutely critical. It's the ultimate backstop for improving performance over time by reviewing failures and for handling situations the automation just can't or shouldn't handle alone.
Like when?
Two main triggers mentioned. Exceeding failure thresholds, like the agent just keeps misunderstanding the user after multiple tries.
Okay,
Yeah.
time for a human to step in.
Yep. And second, before high-risk actions, canceling orders, big refunds, anything with significant consequences, get a human sign-off. It's just sensible risk management.
So bringing this all together, it's clear these agents are a big deal, a new way to tackle complex workflows.
Definitely. Huge potential for tasks involving nuance, unstructured data, messy rules where old automation fails.
We've covered the core bits, the model, the tools, those crucial instructions,
Yeah.
and how to orchestrate them single agent or multi-agent patterns like manager or decentralized.
And underpinning it all, the need for robust, layered guardrails and that essential human oversight loop. Safety first.
It really feels like building reliable agents is an iterative journey. Start small, validate, learn, expand.
Exactly. It's not a one-shot deal. But get these fundamentals right, and agents really could automate entire workflows with, intelligence and adaptability. That's the promise.
Okay, final thought for everyone listening. Think about your own work, your own processes. Is there a workflow that's clunky, manual, full of judgment calls? Could that be a candidate for an agent? Something to chew on.
Definitely worth considering. And if you want to dive deeper, the guide mentions resources like the API platform, OpenAI for Business, the developer docs, plenty more to explore there.
Great stuff. Thanks for joining us for this deep dive.